Okay guys, just going to go through the derivation of the magnification of a magnifying glass. Right, remember we start off with this diagram here. We say if we're trying to see an object of height h0, we want to see it as big as we can with the naked eye, unaided, then we want to put it at the near point, which is a distance d away from us. Now let's define the angle at which is subtended by that object as theta 0. So that's the angle which is subtended by the object at the near point. So that's obviously the biggest we can see it with the unaided eye. So if we want to see it any bigger, we have to use a magnifying glass. So remember, for a magnifying glass, we want to have the object within the focal length, f. So let's put this object here. Now remember our lens diagrams. Remember that one parallel beam would go to the lens and then be refracted through the focal point, and another would go straight through the middle. And if we backtrack those rays, then where they converge is where the image would appear to be. Now, if you think about it, the ideal place for the image to be formed is also at the near point, because we want that's the closest we could see it without straining. So the image distance would in fact be equal to the distance to the near point d. Now, just to define some other things in this diagram, the object is here, so obviously this distance here can be defined as the object distance u, and we also have another angle. So the angle here, the angle to the top of the actual object, happens to be the same angle. If I continue, you can see, same triangle, it happens to be the same angle that is subtended by the image. So let's call this theta I, as in the angle subtended by the image. And we can define a few other things now. Right, so let's say that if this angle is small, then theta naught is equal to h naught all over d. And again, if this angle is small down here, then theta I would be equal to h naught over u. It just comes from simple trigonometry. Now we say that let's define the angular magnification of the magnifying glass is obviously how much bigger this angle appears to be compared to the original angle that we could only see with our eye. So how much has the magnifying glass actually magnified the image? Well, that would be the angular magnification would be the angle subtended by the image divided by the original angle subtended by the object. Now we have theta 0 and theta I here, so we can substitute these two values into this equation. So we get that the angular magnification is equal to h naught over u divided by h naught over d. And then I can simply flip the bottom one cross multiply, and I'm left with d over h naught times h naught over u. The h naughts cancel, and I'm left with the angular magnification, m, is equal to d times 1 over u. Now I've left 1 over u like that on purpose, because I don't want u to be in the equation. I actually want to find out what it is in terms of f. So I remember my lens equation. I get 1 over f is equal to 1 over u plus 1 over v. But remember that v is equal to the distance to the near point d, but it's also virtual. And because it's a virtual distance, this becomes 1 over u minus 1 over v over d, because I substituted in for the distance to the near point. Rearrange that, I get 1 over u is equal to 1 over f plus 1 over d. And then this becomes very easy, because 1 over u here, we can substitute for the 1 over here, 1 over u here. So the angular magnification becomes d, let's move this, sorry, d times 1 over f plus 1 over d, which is equal to d over f plus d over d. So the angular magnification is equal to d over f plus 1. There's a second case that we need to consider, which is when we place the image at different place. So let's again start off with an object placed at the near point, height hi. that's h0. Placed at the near points, the distance away is d, and then the angle subtended by the object, theta 0, would equal h0 over d. Now let's place, again, let's use a magnifying glass to try and magnify the object. Okay, but this time we're going to do it slightly differently. Now instead of placing the object at the near point, sorry, the image at the near point, what we're going to do is we're going to place the image all the way over at infinity. Now to do this, we need to place the object at the focal length f. So let's put the image at the focal length f. Then we construct our ray diagrams again. Okay, we get these rays coming from the object. Now remember, these rays here are then effectively parallel and appear as if they have come from infinity. So our eye can still create an image from that. And let's call this angle theta. So this angle theta I would in this case be theta I would in this case be h0 all over, again, the object distance. But the object distance is actually equal to f because it's at the focal point. So h0 all over f. Now we define angular magnification as theta I over theta naught, and we can substitute in our values. So I have h0 all over f is equal to d over h0. H0's cancel, and I get the angular magnification is equal to d over f. So we have two different equations. We have angular magnification is equal to d over f, and we have angular magnification is equal to d over f plus 1. The first is when you place the image at infinity. The second is when the image is at the near point, or a distance d away from the lens.